Um, it's all fine to me. I mean, I'm just going on. As a matter of fact, I'm going live right now, but I'm just keep going. And, so I can go in here. Okay, we're live. So, apparently I cannot attack the, let me try something. Well, the problem I ran into last time was related to not finding the right problem in the book. Meaning, here, let me see if I can find, this lecture may be kind of a washout here, so, but luckily we're way, way ahead. Let me see. Let's see if I can connect through here. This is silly to have to do this. All right. Here, I can see the U drives. Hmm. Okay, go in here. So, last period, I was looking at this, and it turns out, okay, I thought I messed up. But in fact, I didn't bring my tablet with me, but in fact, the problems were numbered funny. You got 1, then you got 2, which is this is the same curve, but you're doing this back portion. And then you got 3. So I should have been looking at 10.1 and 10.3 in the back of the book. Instead, I was looking at 10.1 and 10.2. And because of that, I thought the answers were wrong in the back of the book. They actually were right. I was just looking at the wrong one. So if you look back at last lecture, okay, you will find that, in fact, he is right. And I was looking at the wrong place. Here's what I mean. That was the answer I got for the first one. I didn't get this answer, but this is the different problem. And I got this one, so you'll find in last lecture, I actually worked this problem correct. And then I worked this problem correct. In fact, I thought this one was what I was looking at. In fact, this is the complementary surface. In other words, I worked this one, got that answer. I worked this one, got that answer. So sorry about that confusion. In fact, both he is right and I'm right at the same time. It's just, this is not the problem I worked. So along those lines, let's see if I can go back. This is about, nope, I was in 10. We can work another problem here related to it, and then we'll call it good. Hang on. Let me do something. I'll start here in a second. All right, so we're going to do this integral. Give me a second. Okay. Let's hit in here. Maybe we'll do a composite body. But we'll do one more integral just for fun and call it quits. Then we'll do a composite body on Wednesday. It's very strange doing things on a virtual desktop and then going back and forth. Okay, like I said, this is what I was doing before. I thought that was 10-2. So I worked this thinking it was 10-1. This was 10-2. In fact, this is 10-2. That's 10-3. And then this is 10-4. I don't know. Let's see. Let's look. Determine the movement of versus shaded area. 10-1. Okay, here's a 10-1 and a 10-2. I'm assuming, yeah, here we go. This is the picture, 2 inches, 5 inches. I don't know, let's see, 10-3. Determine the for the area by the X and the Y. We can do this one. Let's see. That seems good enough. I should be able to finish that one fairly quickly. Now, let me see. Okay, where? All right. We will see if I can do a connection. Okay, I was able to connect and grab this picture. Let's see if I can drop it from, and apparently I can. So here we go. I don't know which one people prefer. Or you could do this one first. Either one, I don't really care. Okay, so here's what we're going to do. We're going to take this block and we're going to run it back and forth this way. So what we've got to do, okay, now, one of the things here is which direction do you want to go? Okay, so in other words, if I take this and consider this a blob, and I integrate whatever this is, it, in this particular case here, it's x squared, but right now I'm just going to consider it a blob, and you're either going to want to do dx dy, or you're going to put the blob in here, in dy dx. Oh, um, which one you do is up to you. I'm going to basically slide myself this way first. Okay, so if I rewrite this equation, I could say y is equal to x squared over 4, or I could say x is equal to 2 square root of y. In order to make my life, let's hope that this launches. Give it a second. You did? Okay. So if I decide, which one of these do I think I like better? Well, let's see. I don't know why. I kind of like that one a little better, but I do. Okay. Okay. Oh, sorry. Let's see. How do I get rid of this thing? That's not what I wanted to have happen. And I can squish that back. Okay, so if I'm going to do this one first, if I like this one more than this one, so I'm gonna select this one. If I'm selecting this one, that kind of means the inside integral is gonna have to have a y associated with it, meaning that I'm gonna wanna go this way. I'm gonna wanna go from, if I give it an x, I go from a y from here to 1 inch. So where's the bottom? The bottom is, this is looks funny, x squared over 4 to the top being 1. And this is, I'm going to go from 0 to 2. So then it's your choice what you want to put in here. Let's look back at the text, which is here. So let's see, he says 10.3. Okay, so let's say it's 10.3, 10.4. That was close. I'm just going to grab the answer first. Okay. There is no 10.4, so we're going to get this one. So IXX is 0.571. I'm sorry, is equal to 0.571. This is what he thinks the answer is in the back of the book. So I'm just going to focus on that one and not the other one. It just matters what you're going to put in the blob anyway. So I am going to kind of, okay, since I can see this, SYMS, Y, well, wait a minute, X, yeah, Y, I really should maybe do X as well. I think it's integral. Now, don't quote me on this. Y squared, and I think, okay, let me go in and get a, this is not CIC filter. I want to, you should be able to see many of these. Okay, a definite integral. Okay, integration interval. I made the text kind of large. Okay, so it's a definite interval of S with respect to V from A and B. So this is something that happens in MATLAB in that it's kind of object oriented, so that there are many different functions that would happen using the int based upon what you put here. So in my case, I'm going to put this one. So I'm just going to copy and paste that. But what I'm going to put is the integral y squared with respect to y, x squared over 4 to 1. Okay, so 1/3 minus x to the 6th. And what was it? Over 192. And now this gets integrated from 0 to that and dx. So I can repeat this. Why am I integrating it to 6? Should be integrating it to 2. Okay, so let's take that function, which still sits in MATLAB, and in fact, I can call it a variable I, and that's, sorry, here's I, so now I integrate I with respect to x from 0 to 2. I think we get 4/7. So this will be 4 over 7, which here's the thing, is when you're doing these integrals like this, he's going to give you back a fraction, and here you go, it's 0.5714, which is in fact what he had right up here. So we got that. Now, here's the thing. Let's go back in, and although he doesn't give us the answer for this one, we can imagine and work ourselves through it by doing this. We'll shrink the page down, do a lasso here, slide it to the right, maybe shrink it down some more, maybe slide it to the right some more. And what I'm going to do is I'm going to come back and try to do decent handwriting so that I can do this. y integral of x squared dA, as opposed to the dy right here. I'm going to do the dx. Now here it might be more conducive to doing it like this. If that's the case, let's say control. If that's the case, and I'll tell you what, here, let's do this. I've never tried this, but I'm going to try it. There we go. So it might be more conducive to writing it like this and integrating along the y. Along the x first. So if I look at this, you have to look at the picture, find out where you're integrating from and to. Okay, here, you kind of ignore the y for a moment, but you know you're going from right here across the page until you reach this point, which is defined by that. So you're going from 0 to 2 square root of y. And this you're going from 0, wait a minute, this is the y, to 1. So you're going up 1 here. Let's perform this interval. Let me shrink it. Come up here. Okay, again, integrate. Now, here's the thing. Let's see. If you're used to MATLAB, what you're seeing here, let me see if I can try to make it so that it fits on the page here. And what you see over here is a bunch of symbolic variables. I made this one symbolic, this symbolic, and this one. So if you go back and hit II, you'll see what it was before. However, I'm going to change that. Okay, my x and y are still symbolic variables. So I'm integrating a function. That function is simply x squared sitting in the term right here. Integrating with respect to x, because that's the integral right here. And integrating it from 0 to 2 times the square root of what? And then put a parentheses there after. Okay, that's kind of a headache, but okay, see if I can remember this. If I can't, I can bounce back and forth. There would be 8. Move it down, 8. Gosh, I've already forgot. Y to the 3/2 over 3. And now I'm integrating this from 0 to 1 dy. Okay. So now I turn around. Okay. I can call that my II now. It's the intermediate integral. And now I'm going to integrate II from, with respect to y, from 0 to 1, 16/15. Kind of a weird number. And so that's the answer to the second part, which is this. And so what you see, this, I'm taking the approach of the standard calculus book, and that is I'll break it into, that's different than what he does in our book. I'll break it into the integrals the way they are. There's not much in the way of interpretations. You just have to be careful about how you're constructing your matrices. I mean, not your matrices, your integrals. And that's pretty much it. That's all there is to this. So again, your whatever function you're given, which, okay, which sit in here, okay, and kind of review. I mean, this is kind of what we talked about last time, this particular problem, and he goes in this mode where he does it this way. So if we took an approach, okay, so, and maybe I'll do that this time. If we look and stare at this problem, and maybe we'll do that next time. We'll stare at this problem and reverse the integration sequence, and we'll see how this thing ends up. It turns out it's okay, it ends up okay. He only found Ix, he never found Iy. So what we'll do is we'll run back. Next time we'll take this example and we'll study it really hard. We'll have a comparative of his little bar, which is a little bizarre bar, which is one way you could look at it, in which, is this a write-up? In which, oh, that's highlighter. Apparently you can use a pen here. No, you can't use the pen here because I'm on a virtual machine. So the pen input, what is this? Oh, it is a pen, okay. So here's an eraser. Okay, so essentially what he does in his particular case is he takes this column, and if you zoom in here, you will see kind of a strange, he uses the value of the Ix. He notices it's about the centroid, uses the parallel axis theorem, and goes through all this. Here's your parallel axis theorem. This is second moment of the area about that x bar. This is your parallel axis theorem right here. And he lands upon this being the answer. A strange contortion that's taken in order to get this interval. So what we'll do next time, we'll focus on this problem to show a parity of approaches here. This is very strange. Okay. So with that, I think we'll call this quits for the day.